Okay, so I've now swapped out for a 16mm diameter drill bit, just a standard stub drill bit. What I'm going to do is open it out to a depth of 7mm, which will allow for my stub on my compound slide being 6.2mm high. If I drill it to 7mm, I know I've got clearance and I'm not going to bind on there. I may do 6.5mm deep, something like that. So from the moment this starts cutting, I'm going to set a 0. I'm going to put my caliper on my tailstock, and I'm going to drill in for, as a starting point, at probably about 6mm. So we'll do that. I'll slow things down a little bit here. Just get my caliper on my compound. Set my caliper to 0. Start drilling. One turn of the handle. Two turns. Three turns. It's a millimetre per turn. 4 turns. That's 5. 5.5. Let's just take a measurement. Measuring about 5.9 travels. So I'm going to stop there. Bring my drill back out and get the flat bottom 16mm drill in. We'll do that in one go. There's the standard 16. And that's the flat bottom version of a 16mm drill. It was a normal 16, but I've ground it on the bench grinder into a flat bottom, and it does cut rather nicely. Okay, similar operation as you've seen me do before. Lock off. Now I know that rule is 1/2 mil thick. I've measured it. It's 0.5 millimeters. I'm going to go about 6.3mm deep with this drill, plus the 1/2, so about 6.8mm. And I'll do that by checking the hand wheel on my tailstock. 1, 2, 3, 4, 5, 6, 6.5, 6.8. Let's bring it back out. Stop the lathe, and the next thing to do is measure the depth of that hole. Okay, so I've put my boring tool post up. I don't think I've shown you this before. It's not a boring tool post, it's a tool post for boring. Basically a circular slug of aluminium which I've bored out, and it takes a 10mm and a 12mm boring bar. And the two bores, it sits in around centre height, so there's no adjustment, no anything to do. Swap it out for what was the quick change tool post, put this one on, lock it down, and I've got my 10 and 12mm boring bars set up. So just to check that drill depth that I've just done, if I bring my lathe tool in to touch the base of the block, set my 0, drop it into the back of the hole and touch the flat bottomed area, 6.25mm. So the step on my compound slide was 6.2, so that gives me 0.05mm of clearance. All a bit close, what have you. I'm going to aim at 6.3 to 6.4. So what I need to do now is to bore out this hole to to just probably 0.05 under 18 millimeters and to a depth of 6.4 mil. So let's get on with it. Let's just touch off. Put a cut on. Just take 0.2 aside to start with. And I'm going to keep going till I get to 6.3. I'll place the bottom of the hole afterwards. Let's just check my diameter. Okay, so I've measured that diameter and it comes out at 16.6 millimeters. So if I put 0.1 on the DRO, it'll take 0.2 out of the hole. So I know I need at least 0.5 out per side, and that'll take me to 17.6. So that's my next cut, 0.5 aside. So wind my tool out, my 0.5 millimeters, and that will increase this hole size by 1 mil to 17.6. Another 0.1 aside will be 17.8, and I'll measure again at that point. Speed it up a touch. Okay, measurement time again. So, final little job I'm going to do on the bottom of this block. I've chamfered the both holes on the counterbore and the drilled hole on the inside, just to break the sharp edges. I've now got my tool set up, like a V-tool set up dead square to the face, and I'm going to put a series of probably 4 grooves at maybe 3.5 mil intervals, something like that, on this face, only very shallow, maybe 0.5 millimeter, to allow somewhere for any dirt or debris to go on the underside of the tool post when it's in service. So we'll get on to do that now. Right, let's come out 3.5 from there. Come on, there's 3.5. Start the lathe up and give it a little groove. We'll slow it down a bit. Out another 3.5, which would be 7. That's too far. 7. Get a bit of chatter there. I'm going to have to polish this surface up afterwards. And 3.5 will be 10.5. Using my digital readout to get these readings that I'm shouting out. 10.5 is coming directly from my digital readout. There we go. And another groove. Slow down a bit more. There we go. And one more groove. Another 3.5 is going to be 14 mil. and that's 14 on my digital readout. On the last groove. And that'll do me. And there you can see I've got a series of 4 grooves in the bottom of the post. That won't reduce the surface area by very much, but should I get very small pieces of debris in there, they should work their way into the grooves on the underside of the tool post when it's in service. Okay, so I've had all sorts of fun setting this up. My plan was to bolt it onto the compound slide, but as it turned out it was way too high compared to the centre line of the lathe, and I just couldn't get the travel on the cross slide to go back and forth in front of my cutter. So what I've decided to do, I've got a fly cutter here up in the headstock, is use a fly cutter, which means I can pass across the face of the block in one hit. So what I've done is used the base from my milling attachment, and don't know if you'll be able to see it, but I've drilled and tapped an M10 hole in it, fitted a 10mm stud with a nut and washer, dropped my tool post down over that stud, sat it on a couple of pairs of parallels to bring it up to centre height, so that the centre height of that block above the bedway is pretty much, yeah, within 4 or 5mm, 3 or 4mm maybe, the centre line of the lathe. Right, so I have done a practice cut, and I've actually machined the far face, which is here. And as you can see, let's see if I can get a better shot of this. It's actually machined quite nicely, and it's fairly flat. Well, it is quite flat indeed. It's within a sort of thou flatness all the way across. So my next step is, having machined this face here, to machine this face, which I shall show you shortly. Now, to machine this face, I have to make sure that this face is running parallel to the axis of the lathe. Quite a simple job. Not quite enough light here, but what I've done is set my clock up, or DTI, dial test indicator, up on the bed of the lathe, put the plunger against the side of the block, tap the block into square in sort of this orientation here, until I get a consistent reading on the clock. Let me just wind the handle across, and it's now running, other than the small little bumps and lumps from the cutting operation, it's running smack on. So the next step is to set it up and machine this face. Now, I'm not actually worried about a dimension across these two faces, as when it's being used, this face here and this face here are actually in fresh air, not doing anything. The only acting faces are going to be this one and this one. So the important fact is that this one and this one should be 90 degrees to each other, and we'll come to that on the next step, but I just need to machine this up nicely. Now, one thing with cast iron, especially as this is the open cast face, is on your first cut, to get under the skin that's on the cast iron. It's got like a glass hard, but if you hit it and get under that skin, it'll machine quite nicely. But if you try and scratch, you know, a thou at a time across this skin, you'll just blunt your tool, because it is actually glass hard. So what I'm going to do is bring it up, touch the tool, switch on, take a 0.5 millimeter cut across the face, and I shall show you that next. Here's something interesting. I've just emptied a load of cast iron filings out of the bed of the lathe. It's metal, and strangely enough, cast iron burns.